For most of history, less than nothing wasn't a math problem. It was a contradiction. You can lose 10 sheep. You can never have negative 10 sheep. So when mathematicians ran into equations that spat out an answer like -4, the reasonable move for over 1,000 years was to just call the equation broken and throw the answer away. Here's the part that should mess with you a little. Some of history's smartest people didn't quietly avoid negative numbers. They looked directly at them and used the word absurd out loud, in print, repeatedly, for centuries. Around the 3rd century, the Greek mathematician Diophantus hit a negative solution in one of his equations and flatly called it absurd. Not wrong, not undefined, absurd. The same word you'd use for a talking dog. Greek mathematics was built on geometry, lengths, areas, physical shapes you could actually draw. And there is no such thing as a rectangle with negative area. If a number couldn't correspond to something you could physically measure, it didn't get to be a number. That single assumption held European mathematics hostage for the next 1,400 years. Meanwhile, on the completely opposite side of the planet, with zero contact with Greece, Chinese mathematicians had already solved the problem, practically, immediately, with sticks. Around 200 BCE, the text known as the 9 Chapters on the Mathematical Art describes a counting rod system where red rods meant a gain and black rods meant a debt. Buy something, owe something. Gain, lose, the rods just flipped color. No philosophy required. If Greece needed negative numbers to correspond to a physical shape, China just needed them to correspond to a ledger, and a ledger doesn't care what a rectangle looks like. Here's where it gets genuinely strange. The same civilization that gave the world 0 also gave the world working negative numbers in the exact same book. Brahmagupta, the Indian mathematician from 628 CE, who wrote down the first real arithmetic rules for 0, wrote rules for negatives in that same text, the Brahmasphutta Siddhanta. He called positive numbers fortunes and negative numbers debts, and he laid out the actual rules. A debt minus 0 is a debt. A fortune minus 0 is a fortune. And this is the part that took Europe another 1,000 years to accept. A debt times a debt produces a fortune. Negative times negative equals positive. Brahmagupta had that nailed down in the 7th century. Continental Europe was still calling it absurd in the 1600s. So how did the same idea that was common bookkeeping in China and settled arithmetic in India spend over 1,000 years locked out of European mathematics? Buckle up, because the excuses genuinely get worse the closer you get to the modern era. Fibonacci. Yes, the same Fibonacci whose 1202 book, Liber Abaci, brought Hindu Arabic numerals and 0 into Europe, actually ran into negative solutions in some of his financial problems. And he did something telling. He only allowed himself to use them when he could reframe a negative number as a debt. The moment the problem wasn't about money, the negative answer got thrown out as meaningless. Even the man importing 0 into Europe couldn't bring himself to trust a negative number on its own terms. By the 1500s, it gets almost comedic. Michael Stifel, a serious German mathematician, wrote in 1544 that negative numbers were absurd and fictitious below 0, his actual words. Girolamo Cardano, the mathematician who published the general solution to the cubic equation, called negative roots fictitious numbers in his 1545 masterwork Ars Magna. He used them reluctantly, like a tool he didn't fully trust, and kept trying to avoid them when he could. Even René Descartes, the same Descartes who invented the coordinate system every student still uses, rejected negative roots of equations as false roots, specifically because they represented, in his words, quantities less than nothing. The father of coordinate geometry still couldn't accept a number below the starting line. And then there's John Wallis in 1655, trying to be generous to negative numbers and instead producing one of the strangest wrong ideas in the history of math. He argued that since a number divided by a smaller and smaller positive number grows toward infinity, then a number divided by an even smaller negative number must be greater than infinity. Negative numbers, in his reasoning, were quantities bigger than infinity itself. It's completely wrong. It's also, honestly, kind of a beautiful glimpse into just how hard the human brain had to work to make an unfamiliar idea fit inside a framework it was never designed for. What actually broke the deadlock wasn't a proof. It was a picture. The number line. A single straight line with 0 in the middle, positive numbers stretching one direction and negative numbers stretching the other, gave negative numbers something Greek geometry had always demanded: a physical location. You didn't need a negative rectangle anymore. You just needed a point to the left of 0. Once mathematicians had somewhere to put a negative number, absurd quietly stopped being a serious objection. And by the 18th and 19th centuries, negative numbers were fully load-bearing parts of algebra. No apology required. Here's the part people skip past. Negative numbers aren't just positive numbers with a minus sign. Their real power is as a direction, not a quantity. The same conceptual jump 0 made when it stopped being a blank space and became an actual number you could compute with. A negative number doesn't just tell you how much, it tells you which way. That single idea is why a thermometer can go below 0, why your bank balance can be overdrawn, why physicists can describe a charge, a velocity, or a force pointing backward instead of forward. Without direction built into the number system itself, you'd need a completely separate vocabulary for every quantity that can go two ways, which is exactly the mess Greek mathematics was stuck in for 2,000 years. And once direction was locked in as a real mathematical property, it cascaded into everything downstream. Algebra needed negative numbers to solve equations that positive numbers alone couldn't touch. Calculus, centuries later, is soaked in negative values, rates of decrease, slopes going down, motion in reverse. Every video game physics engine, every stock chart showing a loss, every weather report giving you a temperature of -4, is quietly resting on a concept that Europe's greatest mathematicians spent 1,400 years calling absurd, fictitious, and false. So, negative numbers were invented, or discovered, take your pick, independently by at least two civilizations that never spoke to each other, formalized with real arithmetic rules by the same 7th century mathematician who formalized 0, imported into Europe by the same 13th century book that imported 0, and still spent the next 400 years being rejected by Europe's most brilliant minds, one of whom decided they were literally bigger than infinity, rather than simply admit a number could exist without a shape to match it. All of that had to happen before a bank could print a negative balance on a statement without anyone blinking. Every debt you've ever tracked, every temperature below freezing, every you owe on a receipt depends on a concept that serious mathematicians spent longer arguing against than they've spent using it. You made it to the end, which means the exit fee is due. 1 subscribe, that's the toll. I'm flipping this tablet around like I'm expecting a tip on a bottle of water, and you're paying it in the form of a like. Don't. And I'm assuming your MHC molecules are incompatible with mine. And honestly, things are about to get real awkward between us. Stay wrinkly, apes. See ya.